Hi guys, today we're talking about direct proportion. Direct proportion just means if one quantity increases, another quantity increases. So for example, if we are going to earn $20 an hour, as my hours increases, so does my money. If I work for 2 hours, I get $40, and if I work for 3 hours, I'm going to get $60. So our proportion, our constant of proportion, if you like, in this case would be $20, because that stays the same. I still earn $20 per hour, no matter how many hours I work. And you'll find in the examples that the thing that doesn't change, the constant, they call it K for some strange reason. Now that other weird symbol here that's on the screen, you'll see that sometimes in questions, and whenever you see that, it just means that one quantity is in direct proportion with another. Let's have a look at how we would apply that to an example. So if I have y is directly proportional to x, I can make an equation out of that. The first thing that's mentioned is y. Instead of that, if it says is directly proportional, you can write that to x. Now the way you're going to then move on from that is instead of writing that weird symbol, you can write y equals k times x, because that strange symbol there just means that it's going to be times k. And it's important to note here that it may not be y and x, it may be r and t. Let's have a look at an example. If I've got the distance in meters travelled by a car is directly proportional to the number of rotations of its tyres. After 540 rotations, a distance of 950 meters is travelled, and they're asking us to find what is the constant of proportionality. So in all these questions, the first thing really that you're going to do is write your equation from that first sentence, and it is written here for you. So the distance d, we write that first, equals k, where it says is directly proportional to, and the last quantity mentioned that will change is the rotation, and that's called r. So that's how we get our first equation. The second thing that we're going to do is they normally give you a pair of numbers which you can substitute into that equation in order to find k. And those two numbers in this question are d, which if we have a look back here is 950, and r, which is 540 rotations. So subbing those two numbers in for d and r in the equation gives us 950 equals k times 540, and then we have to solve that equation. So to get k on its own, I need to get rid of this times 540 by doing the opposite and dividing by 540. And of course, whatever I do to one side of an equation, I must do to the other side. So that cancels out the 540 on the right hand side and just gets us with k. On the left hand side, we've got 950 divided by 450, which gives us 95 on 54. Now we might as well leave it like that because we need that to answer the next question. So what distance to the nearest meter will be travelled after 800 rotations? Okay, so our new equation that we're going to write down, instead of D equals KR, K, remember, stays the same. So it's D equals 95 over 54 times R, and that's our new equation. I'll try and write that a bit better for you. I now have to substitute the number 800 into that equation because it says I want the distance when R is 800. So therefore D equals 95 over 54 times 800, which gives us 19,000. And remember, that's in meters. So we can change that to then kilometers by dividing by 1,000. That gives us 19 kilometers. Let's try one more. How many full rotations will be needed to cover 360 kilometers? Okay, so it tells us to convert the kilometers to meters first of all. Okay, so our distance is 360. Let's do a little calculation over here. We've got 360 kilometers equals 360,000 meters, multiplying by 1,000. We've already worked out that K for this question was 95 over 54. And we've got our equation already as being, let's have a look. D equals 95 on 54 times R. And this time they've given us the distance, which is 360,000. So I'm replacing D with 360,000, and I'm going to solve that equation to calculate R. So in here there's a times sign, which basically means that to solve this for R, we need to divide the other side, 360,000, by that fraction. And so you can just put that into your calculator and hopefully we'll get the right answer, which gives us 20,463 rotations.